Let's talk about steam sterilization. One may wonder how you get your medical instruments sterilized and how do we measure the sterility of the medical devices that we use for surgical procedures. Behind every surgical procedure, there will be surgical instruments and devices that are used by the surgeon. Before these instruments make it to the operating room, they undergo a series of processes from cleaning, inspection, lubrication if required, assembly, and then sterilization. And before they go into sterilization, whether it's high temperature sterilization or low temperature sterilization, there are equipment that are used to sterilize them. And before we use these equipment, we have to test these equipments for efficacy to make sure that what we're using for sterilization actually works in the process. For my location, we use steam as a sterilant for most of our surgical instruments. And in order to test the efficacy of this machine behind me, it has to go through 3 qualification testing during the sterilization cycle. Before we start our day to use this machine, it has to go through a process called a Bowie-Dick air removal test. It is a dynamic air removal steam sterilizer, and before it sterilizes any instrument, it has to be done in a vacuum that is free of air. It means that there is no air present in this chamber behind me. And in order to find out how it's done, we use a type 2 chemical indicator, which is the Bowie-Dick air removal test. And remember, this might not look the same as what you might use at your facility. This Bowie-Dick air removal test is manufactured by 3M. This test is ran first thing in the morning, and it's to test this chamber to make sure this chamber is taking out all of the air from the sterilizer before the sterilization process starts. After this process is completed, we get to inspect the indicator in here to make sure it passes. When you run your Bowie-Dick test, your results should look like this, an even black coating across this result page. If there is a circle in here that's gray, it means that the autoclave is not taking out air properly, and it should be referred to your supervisor or the maintenance group to make sure that this sterilizer is properly getting air out. The second test that is done will be along with your first load of the day. It is recommended that whenever you run your first load of the day that includes medical instrumentation, you run it with a process challenge device. And our process challenge device of choice is this biological test pack, which is also manufactured by 3M. Within this test pack, you have a type 5 chemical integrated indicator, and then you have a biological indicator also, which is filled with a spore called the Geobacillus thermophilis. And why do we use this process challenge device? This is to measure the efficacy of steam sterilization within the autoclave. When we use this device, we are using the hardest to kill harmless microbial life form, which is a heat-loving bacteria. The rationale there is that if this microorganism can die within the process of sterilization, it means that every other microbial life form on your instrument has died. After the sterilization process is done, we will incubate this biological spore, and once it's done, it should show within the result that there is no life form or there's no growth within the ampoule of the biological test pack. This is what it looks like after the sterilization process. Your chemical integrated indicator changes color from white to black. If you notice the difference here, this is what it looks like before it goes into the autoclave, and this is what it looks like after it comes out. It has a change of color. These 2 items, the chemical indicator, your chemical indicator, and your biological ampoule will be red. Whether it's a favorable or unfavorable result is how we determine whether the load within our autoclave has passed. Your third examination will be a physical printout. During your sterilization cycle, your machine prints out a detailed graph of the process of the sterilization cycle. And on this graph, it tells you the exposure time or the parameters that your instrument should be exposed to based on what the manufacturer says. And usually the manufacturer gives you an indication or an instruction on how to sterilize instrument. For example, this process or instruments that we sterilize requires us to sterilize the instrument for 4 minutes, a minimum temperature of 270 degrees Fahrenheit. Based on the manufacturer instruction, we have to now physically verify that we met all of the required numbers by the parameters. So we're going to go on here and physically check to make sure that we met the 270 degrees Fahrenheit and then we met the minimum temperature, minimum pressure, and we met the required minutes that it should be exposed to. If we check our physical or chemical indicator and our biological test back, and if everything passes, it means that our load in here met the parameters and requirements for sterilization. The reason why it's important to check the efficacy of the sterilization cycle, we do not guarantee sterility. And one may ask, but you go through all the process, why don't you guarantee sterility? We don't guarantee sterility because there might be source still on the instruments that we sterilize that we didn't see. Or second, there might be a failed load. In as much as your chemical indicator, biological, and your physical may pass, sometimes a tray within this load might be wrapped up too tight that disables the sterilant from entering the tray to render them sterile. But in order for you to run a good sterilization cycle, it has to have those three qualification testing, which is your chemical, biological, and physical print tests that will verify and stands out for you to assure that your instruments were sterile during the sterilization process. So that's what happens in order to sterilize a load. So there's a lot that goes on behind the scene before this tray makes it out to the operating room. Hope that helps.